Today, our topic is related to kinematics, which was done in the previous topic for the linear motion over there. Today, we are going towards projectile motion, which is not a linear motion that should be in a curved path. For example, you are throwing a ball from here and it is following this track over there and it is being falling down here. It means now he is going a little bit up and also going along x-axis over there. And whenever we are taking to study the motion in two dimensions, then we can say it is a projectile motion, which is following a trajectory properly over there. When an object is following a parabolic trajectory, parabolic trajectory, parabolic trajectory, parabolic trajectory. Like in this shape, this is a parabolic shape over there. In is following a parabolic during its motion in two dimensions. During its motion in two dimensions. And two dimensions like XY plane over there. Then we can say it is using a horizontal tract over there, which is called its a range over there. And it is getting some height of flight, height of projectile over there, and the time which we will have to take into account that how much time he is in the air. For that purpose over there, we should have to take into account. And if I say it is in 2D shape over there, then it means, for example, an athlete, a football is hitting his football, and he is giving this direction in some speed of velocity over there, then making some angle theta over there also. Then its horizontal motion is according to Newton's first law over there, Newton's first law of motion. I will say that law of motion, if I ignore the effect of air over there, effect of air resistance, neglect the air resistance there, then horizontal motion is not being disturbed. So my horizontal component of velocity Vx remains constant over there. Only changing that is the vertical component of the velocity. So Vy is changing according to Newton's second law over there, that it is going to go under the action of gravity, the action of gravitational acceleration g over there. Then I will say here that it is at its maximum height. My Vy is equal to 0. And then again, when it is coming down, it is showing the positive acceleration over there. And for maximum height, it is taken as negative g over there. And while reaching at maximum height, it is 0. And when I am taking is as again hitting the ground, then Vy is also having its max value again over there just before hitting over there. So for that purpose, if I say what will be my initial velocity or my horizontal component over there, Vx will equal to V cos of theta and Vy is equal to V sine of theta over there, but it can change. So my velocity, final velocity Vy will be equal to u minus gt, and that u should be taken according to its vertical component. U sine of theta minus gt will be my final velocity for vertical component at maximum height over there. or not at maximum height, I can say it is decreasing step by step over there. So that is being used over there in the form of Vy component to be taken in the form of velocity over there. For all of these calculations which are involved during this projectile motion, I will say here that you will have to go for horizontal range, you will have to use the formula range as r is equal to range or distance, horizontal distance over there, Vx multiplied by t, horizontal component of velocity should be multiplied with time. No more confusions about it. It is just like distance is equal to speed multiplied time. Take the horizontal component of velocity, take the time, just multiply it and get the horizontal range. And for vertical height over there, just go for it. That how to get the vertical height over there, that is half gt square. Just use this formula whenever, for example, he is saying some person is standing at this height and he is falling and this is the trajectory. What is its vertical height and how much height he's available just before hitting and to the base of the source. Ignore that how much horizontal displacement is being traveled. Sometimes it is being asked what is the displacement. Then use the Pythagoras theorem for calculating this magnitude over there. Don't take if he is asking towards average displacement to count over there, then get this height and horizontal range height distance over there and take the displacement for this section, then average displacement over average time, then total time, like that, to get the average velocity. If he is going to take only towards how much distance is being traveled according to average speed, then both should be added. No more confusion over there. But for displacement, you will have to go for the magnitude by using the Pythagoras theorem. For base square plus perpendicular square should be taken. If I take my speed as a vector quantity over there, I can simply say here, for example, this is my horizontal component. This is my vertical component over there. So it is having x-axis and y-axis over there. So it is x dash. It is y dash over there. And there is the velocity which is present over here. From here to here, I say this is the magnitude, or this is the velocity, which is an athlete is going to push over there. By vectorically, I am going to show it here that this is the velocity. And along x-axis, it is having its component as Vx, and it is having its velocity as Vy. And this is the angle with which it is launched over there. So for this purpose, when I am saying that I am taking the vertical component as a subject, then I am saying I'm using a trigonometric ratio there, that sine theta is equal to perpendicular, that is Vy over Vy is equal to Vy over V. So from here, I can say it can be written as Vy is equal to V sine of theta. And if I'm taking the cos ratio over there, then I say cos theta is equal to Vx over V, which can be written as Vx is equal to V cos of theta over there. And for getting the direction, I will say here theta is equal to tan inverse Vy over Vx. And for getting the magnitude of this velocity over there, I will say V is equal to Vx square plus Vy square in the form of square root should be taken. And remember that while doing the A-level papers, we will need only the equations of motions. And for horizontal displacement, I said for range, you are using Vx multiplied by t. And for height of projectile, you are using half gt square over there. So both will be used. And for I said for average velocity, if he is going over there, then you are using the Pythagoras theorem to calculate average displacement, and later on total time over there. So for that purpose, when average velocity is going on, never add both displacements present in the form of horizontal and vertical components over there when downfall of the object is being observed over there. Here, I am also going to add some MCQs questions, which were mostly directly asked. Derivations are not required for range, for height, and for time of flight. Formula derivations are not required, but these formulas are given only in MCQs. So I'm giving as a reference to the points to those formulas. Just try to memorize them. No need to go for derivation. No need to go for the formula practice, because in paper 2, he is not asking any question related to that one. That questions he will ask related to kinematics will be done on the basis of 3 equations of motion, which were described in the previous class over there. And try to focus on for these formulas, which I am writing right now, is required only for MCQs questions. And that are not too much also. And that were done with the previous, like if I go for previous 10 years papers, then I can say in 5 to 6 times it is being asked over there. For range, we use the formula u square sine square theta over 2g. Height is range. Wait a second. I have put this is the height formula which I put it there. It is height formula. For range, it is u square sine 2 theta over g. For height is u square sine square theta over 2g. And for time is 2u sine theta over g, like that. So this is the way how you can calculate range, how you can calculate height of projectile and time of flight. In FSC exams or in other boards, maybe these formulas will be manipulated for the numerical calculation over there. But in our A-level physics, these are given only as a multiple choice questions in our paper 1, and remaining all other sections are not being touched in kinematics portion over there. So try to focus to memorize these formulas is the best option. No need to go for derivations and manipulating them according to their numericals over there. And projectile motion, where he is using, we can simply say here for range, he is using these formulas. That is the horizontal displacement, height of projectile, and average velocity for average displacement to be taken. Average speed, we know that is total distance traveled over total time taken. But in average velocity, we take average displacement by using the Pythagoras theorem. These were the tricky little bit points which I have explained over here. I think so these will be much supportive for you for solving the past papers, as we will move on towards the past paper after completing the whole syllabus over there of ACE physics. Then we move towards past paper solution also. Inshallah, I will explain in complete detail. Kindly subscribe my channel and like and comment and share on my picture videos also. Thank you so much for today. See you in the next video with the past paper questions of kinematics over there.